Casting is a process that converts the data type of a value into another data type. There are pretty much two different kinds of casting: widening type casting and narrowing type casting. Let's leave programming out of the picture for a second here and move our thoughts to my kitchen cabinets. And let's say I have a jar of pasta. If I have a bigger jar and I want to pour the pasta in the bigger jar, I'm sure this will fit. But if I have a jar with pasta in it and I want to pour this pasta into a smaller jar, I need to estimate whether this will fit or not. If my bigger jar is not completely full, it might fit. But if it's completely full, or at least fuller than what will fit in the small jar, it will not fit. This is a more careful process. Alright, back to Java. The first one, pouring the pasta in the bigger jar, is widening type casting. This does not need to happen explicitly. Java can do this automatically for you. There is no risk of the value not fitting in the new type. An example of this is casting an int value to a long. The value of a long can be bigger than an int, so it will always fit. Narrowing type casting is pouring the pasta of the bigger jar in the smaller jar. This will not always fit, and therefore it needs explicit type casting. This happens, for example, when you want to store the value of a long into an int. This will often fit, but not always. Therefore, this needs to happen explicitly when the programmer is sure that it will fit. On this slide, you see the explicit cast happening. It's the int between two parentheses. This tells Java to update the type to whatever is between the parentheses. Fun fact, both types of casting are happening in this example. The first time is when we assign 123 to long. 123 is an int, but we store it in a long. This widening casting happens automatically. The second one is an explicit cast. The int between parentheses changes the type of the long to an int. And in this case, we're sure that it will fit. Let's recreate our example. Let's say we have some sort of long L and we store a value in here. And then let's say we have an int x and we want to store the value of the long in there. As you can see, we get a compile error. Why? Well, long is potentially too big to be stored into an integer. In this case, I'm sure it will fit, so I'm going to cast it to an int. And as you can see, the red squigglies goes away and it looks good like this. We could do something similar with double and a float. So remember, the double is bigger and more precise, so let's just store some sort of value in a double. And actually, this will also fit in the float. So I want to do this, but I cannot say this because the double might not fit into a float. What I can do, I can cast it to a float. And then IntelliJ is happy again. So what happens if I try to do this, but actually it doesn't fit? Remember that char was an unsigned variable. It cannot be negative. So let's just create some sort of, I don't know, a byte b. And let's store -23 in there. And then I have a char c, and I want to store the value of my byte b. Well, in that case, I need to cast it to a char. Then if I cast it to a char, it will compile just fine. But will this run just fine? Well, let's run it and then find out. So let's talk about the funny thing that's happening here. Why does this work? Well, this has a bit to do with the way Java is working. Java mandates that any of the arithmetic operations on the primitive types is not going to either overflow or underflow. So what's happening here is it's actually being changed into a rather big number. So stay with me when I'm going to do the next conversion here. So well, if I were to print this is not going to be very helpful, but let me show you what this does. As you can see, it shows an arrow pointing to the left. But actually, I'm going to be helped more with the numeric value. That's going to explain it a bit more to us as well. So Instead of doing what we're having right here, I'm going to say int I, and I'm going to assign the value of c to it. And then I'm going to print the value of I. You can see the numeric representation of our char. And you can see that, in fact, it's a really big number. So we try to assign -23 to it. And then what happened is that it turned into a really big number. This is because it doesn't allow us to have an overflow. So instead, it goes to the maximum value and starts from there. So just to make sure that this is still clear, so the maximum value of a char would be 65,535. So in here, if we were to add 1 to it, we would now get 0 instead. And this is because the char will not overflow. Instead, it will just go to the other end and continue from there. So this is going to be a problem though, and this is very funny because it's related to casting. So it says require type char provided an int. Well, this operation, it's an int. So instead, I'm going to cast it to a char, but I need to put this between parentheses in order to cast the outcome of this to a char. After that, I'm going to print the value of the new char. And as you can see, this is not very helpful again. So instead, let's go ahead and cast it to an int. And now you can see it's 0. So if we're for a primitive at its very maximum, and we try to do an addition that exceeds its maximum, it's going to go to the smallest value and proceed from there. Likewise, if we're at its very minimum, and we try to deduct even more from there, it's going to go to the very end and continue from there. As you can imagine, when they created bank accounts in Java, they did not work with primitives to hold the balance of your account. Let's say unfortunately. We have seen how we can change the type of a value using casting, and that we need to be very, very careful with doing this in order to avoid unexpected surprises.